Hello and welcome. This is Computer Science 2, and in this video we're going to give an introduction to the course by walking you through Lab 1. So before we get started, you're going to have to do a few things on your own computer. First of all, you're going to have to claim your CSE account, which you can do by going to this website. Now these links will be available both in the handout on the lab as well as the video, so no need to copy down the URL. If you already have your account, you can of course reset your password if you need to, if you've forgotten it, or you can recover your CSE login through the same website here. The second thing that you're going to have to do is download and install Java, and you can do that from Oracle's website. You may already have Java installed in your computer, but what you need for this course is the Java Development Kit, the JDK, and that's located right here. We recommend that you download and install the latest version. As of this recording, that would be 15.0.1. But of course, you should download the latest version for yourself. The third thing that you need to do is download and install Eclipse. Now, if you want to use your own IDE, Integrated Development Environment, that's perfectly fine. But all the instructions for this course will assume the use of Eclipse. It's free, it's widely used. There are some other popular IDEs out there, NetBeans, IntelliJ. If you want to try those out for yourself, you're free to go ahead and use those. Now, I won't go through the full process here, but when you download it, you're actually downloading an installer. Make sure that when you install it, that you choose Eclipse IDE for Enterprise Java developers, not the regular Eclipse for Java developers. The Enterprise version. We're going to be using several of the features later on in this course. Once you've installed both of those things and fired up Eclipse, you'll of course have to choose a workplace. This is where all of the code and other artifacts for your projects will be stored. Anywhere on your computer is fine. Make sure that you're saving it on your local computer. If you've got a network drive or something like that, it's probably not going to be better to save on your local hard drive rather than connecting remotely to one of those. It'll look something like this when you start. This is just the welcome splash page. You can go ahead and close that out. Over here on the left, you have a project explorer. We don't have any projects created yet. In the middle here, we've got our editor, but of course we don't have anything open yet. And there are several other panes with different tabs that you may be using later on. To get started, we're going to actually check out a partially completed project from GitHub, the actual project for this lab, in fact. Now to do that, you're going to have to open up a Git perspective. Right now, we're in the Java perspective. The perspectives can be found up here. This is the current perspective. Now to add a different one, you can go ahead and click this button and select the one that you want. In this case, we're going to want to open it up a Git perspective. Now this opens up different panes in a different context in which we can work. So now we're going to be working on Git stuff rather than Java stuff. We're going to clone a current repository, which you can do by clicking this link, or later on, these won't necessarily appear. So what you want is this button up here. When you hover over it, it tells you what that button does. Clone a Git repository and add the clone to this view. Now you need to provide a URI or a URL to the actual repository. All of the repositories for this course are hosted on GitHub. There's the URL for this lab. You don't need a username and password because this is a public Git repo. But of course, if you were going to use a Git repo, private one for yourself, then you would need to provide a username and a password. I'll show you that in a later video. Click Next. Make sure that Master is selected. Click Next. Now it's going to want to save all of your Git projects into a subfolder called Git here by default. That's not what we want. We actually want everything to be stored in our workplace folder that we established before. I put that on my desktop originally. Wherever you put it, make sure that it's the same as your workspace. Otherwise, you'll have code in two different locations, and it'll get somewhat confusing. The second thing that you need to make sure to do is import all existing Eclipse projects after the clone finishes. If you don't do this, then you'll just have to have an extra step later on. Now, understand that we're still in our Git perspective here. If I expand this out, it's going to show me all of the things related to the Git repository, including the code and the artifacts available here. But this is not where we compile and run things. In order to do that, we need to switch back to our original perspective over here, the Java EE perspective. And we can now see that the new project has been imported into our workspace over here. And when I expand that out, I can see everything that was available in that project. Now let's back it up a little bit. Let's go back to the Git perspective here. And I want to run through that one more time, but I'll do it a lot quicker this time. What happens if you forget that step that I just told you and it doesn't import? Well, now it's available over here as a repository, but over here in our workspace, it hasn't been imported yet. If you accidentally forget that step, it's okay, you can still recover. All you need to do is go back to your Git perspective, right-click, import projects, hit finish, and it'll now be over here. So now let's actually run a program here. I'm going to expand out my Project Explorer over here, and you can see that there are a couple of source folders. For example, if I expand this one out, then I see a package called unl.csce. Packages are Java's way of organizing code. They're literally nothing more than a bunch of directory structures. If I were to open this up in my workspace, in fact, let's do that. Here's the directory structure. In the src directory, which is short for source, we've got main and test. Under that, we've got Java, unl.csce. There is the directory structure corresponding to the package structure up here, unl.csce. Packages are nothing more than folders and subfolders, or directories and subdirectories. Within that, we've got three Java files, birthday.java, statistics.java, and statisticsdemo.java. So let's go ahead and open up the statisticsdemo.java file first by double-clicking it. That'll open it up in our editor over here. To give myself some more room, I'm going to go ahead and close these tabs over here. If you don't want to close the tabs, you can actually move them to a different pane. For example, you can drag and drop this tab down to this pane up here. You can change the size of the panes if you want to give yourself some more real estate. Now, this class has a main method. Classes are only executable, and you can only run them if they have a main method with the signature public static void main with a string array as its only parameter. I'm going to go ahead and run this program now by clicking the play button up here. Don't worry about those errors right now. We're going to fix them in a later exercise. Down here is my console. This is like running from the command line where you have an interactive program, and it's now prompting me to enter the number of integers that I want to run some statistics on. So let's go ahead and just enter 4 numbers. As input, we'll go ahead and put in 5, 10, 15, and 20. The sum is 0, the average is 0, the highest is 0, the lowest is 5. Those are clearly wrong. But this is how you execute a program. So our next step is going to be completing this program. You can see here that to compute the minimum, the maximum, the sum, and the average, we're calling all of these methods over here in this other class called statistics. Now you can go ahead and open that up directly by double-clicking over here this other class, or you can hold down the command button, hover over it, and it becomes clickable, and it'll take you right to that class. You can see here that we have several to-dos. We have not yet implemented the getSum method or the getMax method. So let's do that now by using getMin as an example. First of all, we're doing some basic error checking here. If the array is null or its length is 0, then we return 0 because the sum of nothing is going to be nothing. We're not computing the minimum here. We're going to be computing a sum. So I'll create a variable called sum and initialize it to 0. Then for each element in the array, this is a traditional idiomatic for loop for arrays that you might have seen in other programming languages. We simply need to add the ith element. Java arrays are 0 indexed, so we start at 0, go up to but do not include the length of the array, and we increment by 1. Then we return the sum. The get average was actually implemented, but it wasn't working before because it uses the get sum method. And the get sum method was not yet implemented. It always returns 0. Let's use the same code to implement the get max method. Again, we do some basic error checking. Now, arguably, the maximum or the minimum of an empty array is not going to be 0 because 0 is not in the array. We may want to handle that differently later on. But otherwise, I'm going to simply change the variable to maximum, and I'm going to assume that the first one is the maximum. Then I'll iterate through the rest of them, and if I ever find something larger than the maximum, then I'll update that variable. That would require me to change 4 instances of this variable. Let me show you a shortcut. Highlight the variable name, right-click on it, refactor, and rename. I'll rename it to max, and all 4 instances have been renamed. And of course, I need to change it so that if I find something larger than the maximum, I update that variable. Let's run that again. That looks much better. You can clear the console output by clicking this X button over here. Don't necessarily click the X button on the tab. If you do, then the tab goes away. At least in this instance, all you need to do is run the program again, and the console tab will reappear. If you want to quit out of a program prematurely, you can always hit the stop button down here. If you ever accidentally close a tab that you didn't mean to, for example, a task list here, and want to restore it, you can search for help on how to do that. And the appropriate menu item will be highlighted. It was Window, Show View, Task List, and it'll be restored. If you want to pull up another tab, there are a whole list of them that you can do. Let's modify this program. Right now it's interactive input, meaning that in the console down here, we interact with the program by using the standard input, meaning our keyboard. And it prints to the standard output, which is of course the console. Let's modify this program to use command line arguments. Now, normally if you were at the command line, you would run a program and then provide those as in a space-delimited manner. We can do the same thing in Java. All of this code here prompts for input, and so it's interactive. I'm going to temporarily comment that out so that it doesn't run. To easily comment out large chunks of code, highlight it, and then press Command/. To uncomment it, you can do the same thing. Now what we're going to do is read the numbers from the command line arguments, so that if somebody typed run this Java program 5, 10, 20, 30, then those are the numbers that we would want to convert from strings to integers in order to use in our array. First of all, I'll create an array. How big does this array need to be? It needs to be the length of the command line arguments that we're receiving from the user. Now we can iterate over that argument array, but they're strings. We need to convert them from strings over to integers in order to add them to our array here. Now we need to set the ith value in our array to the ith value in the argument array, but converted to an integer. Let me back up a little bit. In Eclipse, you can have code completion. So when I have the integer class here and go dot, a whole bunch of options come up. And if I hover over one of those options, I can read the documentation over here of what that function or what that method does. In particular, I want to parse a string and convert it over to an integer. Now, it's not necessarily apparent what the command line is in this context, because if I just run this, I'm going to get a bunch of zeros because I have not provided the command line arguments. I didn't actually type run this Java program 10, 20, 30, 40. What I need to do is I need to provide those command line arguments. To do that, I can use a run configuration. So instead of hitting the play button up here, I'm going to hit the arrow button right next to it, come down to run configurations. Here's the statistics demo that I've been running. And over here in this tab, you can provide arguments. 10, 20, 30, 40. Apply that and run it. And now you get the proper output. Let's take a look at some other features of your IDE. First of all, I've got several folders over here that don't have anything to do with my code. I've got a lib folder, which is short for library. And in that, I've got a bunch of external libraries here. There is a library called Javadocs, which is an older library used for computing and processing dates and times and differences and durations between times. But it's not currently being used by our project. As you'll see over here in the birthday.java program, when I open that up, I've imported a bunch of things from that library, including date, time, interval, and period. But it's registering a syntax error here, a compiler error. That's because I've not added this jar file, this Java archive file containing a bunch of library functions to my project. Let me do that now. To do that, all you have to do is create a lib folder, drag and drop some jar files, whatever you're trying to use. And to add them to your build path, you right-click the jar file once it's in there, build path, add to build path. And once you've done that, then the compiler can see all of those referenced libraries. I've already have a referenced library here called JUnit that we'll talk about momentarily. But now we've got this other external library as part of our project, and we can use it now. Now, what does this program really do? It's a mess, right? That's because I didn't follow proper styling procedures when I wrote this program. It's all right. We can use the IDE to help us clean it up a little bit. I'm on a Mac, so I'm going to hit Shift Command F, which is short for format. And it cleans up your code automatically. If you're on Windows, it's Control Shift F. So again, what does this program do? This is some sort of Java program, I guess. I'm not really sure. Bad at documentation, etc. Right? It's good to make sure that all of your non-trivial classes and non-trivial methods all have proper Javadocs comments on them. So in this case, I'm going to erase that documentation, and I'm going to put in my own Javadocs. Now to do that, I'm going to go ahead and use the following style. / ***, and then hit enter. And it'll automatically generate these doc style comments over here, sometimes with annotations. Now what this program actually does, we'll find out as we run it, but it computes how old you are given your birth date. Let's run it and find out. Nothing happened because we haven't actually written this program yet. Note that we've got a to-do down here as a self-directive to ourselves that we still need to implement this. One great thing about the Eclipse IDE is that if you use this format of putting in a to-do as a comment, is that you can go to markers and look at Java tasks and see everything that you have yet to do that you may not have done yet. For example, back over in the statistics program, we've not yet added documentation for our getMax function. Let's do that now. Again, Javadocs style comments start with a /**. Hitting enter will automatically generate these annotations for you. Now we can go ahead and write proper documentation for this. The great thing about this, now that that task is gone, is that you can hover over the method and read your own documentation. You could do that from any other class as well. Not only that, but doc style comments allow you to insert basic HTML elements. Which you can actually click on within your IDE. And it'll open up a basic browser. Now we've already included code here for you to compute the actual interval, days to your next birthday date, and the days remaining until your next birth date, as well as how old you are in terms of years, months, and days. What we're computing here is the age of Java, which was born on January 23rd, 1996. So let's go ahead and produce some output here using system.out.println. System.out, that is the standard output. And so in terms of Eclipse here, that's going to be the console down here. Println is shorthand for that anything that you put inside these parentheses is going to print it to a single line, so the end line character will be included for you. Some alternatives would include print or printf if you wanted to use printf style formatting that you might be familiar with. Let's go ahead and print out a message. Greetings, and then we'll add the name. The plus here in this case is a concatenation operator. It's going to take that first string and that second string and concatenate them together. You can string as many strings together as you want. As well as other variables, including non-string variables like years, months, and days. That's a pretty long line. You can go ahead and break it up into multiple lines if you want, so that it's more readable. Or again, you can use that formatting trick, and it'll do it for you somewhat. Let's see how old Java is. 24 years, 10 months, and 7 days old. And of course, we can go back to the drawing board and fix some formatting if we want. Let's go ahead and add some code to see how many days there are until our birth date. If the days remaining is 0, that means it's our birthday today. Let's go ahead and wish ourselves a happy birthday. Otherwise, we'll inform the user how many days they have until their next birth date. There are 54 days until we celebrate the 25th anniversary of Java. Go ahead and play around with other dates and other names. The last thing that I would do is draw your attention to the fact that the style still isn't ideal here. Typically, you follow a lower camel casing convention in Java for all of your variable names. Month, date, and year are all fine, as well as name, because they're only a single word variable name. But B-Day, that could be improved. Let's go ahead and use the same trick that we had before. Refactor, rename. And it's changed everywhere we have a reference to it. Other languages encourage you to use a lower underscore casing convention, but in Java that's not usual. A lower camel casing convention is much preferred. And now that our task is done, we can remove that to-do marker. And we're done. To complete your lab, you're going to have to make sure that everything works. All of our labs come with a JUnit testing framework, which is a collection of unit tests designed to make sure that all of your code actually works. The JUnit tests are usually in a parallel folder called test in the same package and directory structure. For the most part, all of the JUnit tests have already been written for you. Feel free to dive into them to understand them better and even use JUnit in all of your projects and assignments. But for your labs, it's already been set up. To run the JUnit tests, you just simply hit the play button like a normal program. Even though there isn't a main here, it still understands that this is a suite of JUnit tests. And you can see here that we ran 10 tests and we passed them all. There are no errors, no failures. If we had not written our code correctly, for example, let's suppose that instead of get sum, we return -42 all the time. We can rerun the tests and see that there are now 5 failures, which is why we have red over here. Maybe a little bit hard to see, but you can actually see that these are all the failed ones. A green check mark means that they passed, but a blue X means that they failed, and you can see why they failed. It expected 6, but the answer was -42. For this one, it expected 55, but the answer was -42. Let's go back and fix it back to what it should be. And run it again to see that everything passes now. Once we're assured that everything passes, we can actually hand this in to the webgrader. The first step in doing that is to log into the webhandin, using the same credentials that you claimed at the beginning of this lab. It'll look something like this, where you can click this and select the files that you want to hand in, or you can drag and drop them directly here. You won't be able to do this from Eclipse directly. Instead, you'll have to open the enclosing folder and drag and drop from there if you want to. To do that, you can always go to Eclipse, right-click it, go to Properties, and see where it's being stored on your computer right here. And in fact, you can even open up that enclosing folder. Once you're there, then you can go to the source folder, to the files that you actually want to hand in, and then drag and drop them. Once they've been handed in, you can go to the webgrader. That'll look something like this. Again, provide your credentials, and select the thing that you want to grade. In this case, it'll be our first lab. For the most part, all of your labs will simply run the same JUnit tests provided in the Git repository. And you can see that there were 10 tests found, and all of them were successful with no failures. Other times you might have expected output and your actual output, and you'll have to compare them to make sure that it actually is working. Good luck completing the lab on your own.